Hello all, welcome to our first remote meetup. We are doing this remote because our speaker today. Welcome to our first remote. Because our speaker today, Tamnai Gopal, is in Silicon Valley and he could not join us. But I'll let him present himself. We are going to talk today about a cool technology, and that is GraphQL. If you have any questions, please use the right side chat, and Tamnai will answer them at the end of the presentation. And Tamnai, it's all yours.
Thanks. Hi, everyone. I hope you can hear me clearly. If my audio gets cut off or you face any problems, just let me know in the comments, and I'll be able to see. So my name is Tanmay, and I am one of the creators of a project called Hasura. It's an open source project, and we try to give you a GraphQL Firebase. So we try to give you like a Firebase experience, but with GraphQL. And in this session today, I'm going to show you kind of how to set Hasura up, how to get productive with GraphQL, and maybe even touch upon the little basics of what GraphQL is like for those of you who have not used GraphQL before. And after that, I'm going to show you a little bit about how we can integrate those GraphQL queries inside an Angular app, and kind of what that integration looks like. It's a super simple kind of toy demo, but that's more to just give you a sense of what the what the API integration looks like. And I'm also going to show you some other features on the Hasura GraphQL engine to show you how you can use serverless to add your own business logic, and where you can kind of add your own GraphQL resolvers, and how you can add event triggers so that if anything changes on the back end, you can kind of run your own business logic to send an email or send out a notification and stuff like that. Cool. So I'm going to start by sharing my screen. Cool. So I hope you guys, I hope everyone can see my screen clearly. And so this is Hasura.io, and what we do is we are an open source project that gives you instant real-time GraphQL on Postgres. Think of this, the easiest way to think about this is like you got a Firebase on top of a Postgres database. It's an open source kind of Firebase, quote unquote, and it runs on new Postgres databases or even on existing Postgres databases. So if you have an existing application that uses Postgres, you can just use Hasura with that existing database. And you'll get real-time GraphQL APIs that you can start using from your mobile or web applications. To kick things off, I'm going to do a live demo for kind of setting up Hasura. So we're going to use Heroku to deploy the Hasura GraphQL service. And you can kind of deploy Hasura wherever you want, on any cloud provider, on your desktop, wherever you like. I'm going to use Heroku because it's the easiest to kind of get productive with Heroku. So I'm going to click on that deploy to Heroku button. Right, and let's call this GDG. So what I'm doing right now is I've asked Heroku to deploy the Hasura GraphQL engine, and also to give us a free Postgres database. So Heroku has a free tier, and the free tier gives you a small amount of a small database that you can kind of save data to, and you can run your own. You can run any container, or you can run your own application for free as well. And so now I have Hasura and I have Postgres, the database running. Let's take a look at what's deployed for us. So that's what the Hasura UI looks like. What I'm going to do is, kind of create a few tables and give you a sense of what GraphQL looks like, right? So let's start off by creating a simple table. So let's call this a user table. Let's say every user has an ID, which is an integer. Every user has a name, which is a text field, and every user, let's say, has an email ID, which is also a text field. So I create this table. This table has actually gotten created on the Postgres database, right? So the table got created in Heroku. What I can do here is, maybe kind of just enter some data here. And so now I have data in my database, right? I haven't done anything. This is just normal database modeling. But as soon as I do this, what you'll notice is that you can kind of start making API calls with GraphQL instantly, right? So I can do query, and I can say, hey, user, ID, name, and I can start fetching this data. And I can change this to read directly, right? Cool. So for those of you who are new to GraphQL, let's just spend a few minutes quickly understanding what's going on, right? So what happened after I created the tables is that Hasura basically auto-generated the APIs for us. And this API is available to us at this particular endpoint. So that's the URL that our mobile or web app will connect to. And that's kind of where we'll make our GraphQL queries. GraphQL queries are typically sent as a post request to these endpoints. So we're making a post request to this endpoint, and we're sending this GraphQL query. So what you see on the left here, and this content here, this is a GraphQL query. For those of you who are not familiar with GraphQL, you will see that this GraphQL query is not, it's a new language, right? It's a new syntax. It's new syntax. It's kind of like JSON, but imagine that you had JSON where the values were removed and you just had the keys, right? So that's what a GraphQL query looks like. The reason why GraphQL is exciting is because you can control what data you want from the client. For example, if I don't want to fetch the email ID information, I can just make a query to fetch user ID and name, and that's what my JSON response contains, right? Under the hood, excuse me. So under the hood, what's happening is that this string is being sent to this URL, and Hasura is basically accepting this GraphQL query string, and it is figuring out what query to make to the database and converting that to a SQL query and making a query to the database and fetching the response for you. If you were writing your own GraphQL backend, your GraphQL backend will have to understand GraphQL queries, talk to the database or talk to other data sources. You may not have a database, and return the response, right? So just to be clear, GraphQL has nothing to do with the database. It may or may not be, you may or may not have a database that serves the GraphQL API, right? It's just that Hasura is auto-generating the GraphQL API for you. Cool. So that's kind of what a GraphQL query looks like. And if you think about it, this is the equivalent of this in the REST world would have been a GET API call, right? If you did not have a GraphQL query, you would probably have had herokuapp.com/user, and you would have made a GET request, and you would have fetched all the data. But GraphQL kind of allows you to selectively choose what data you want to fetch, right? Now what we're going to do is kind of see what the graph in GraphQL looks like, right? So let's create another table. And let's say that every user has a bunch of addresses, right? So we have an address table, and every address has an ID. Every address belongs to a user ID. And every address has the address itself, which is a text field. And let's say for user ID 1, I live in San Francisco, and I live in Bangalore in India. And so now I have two addresses for the same user. What we want to do is imagine that you're building a profile page. And what you want to do is you want to make one API call to fetch the user and the address data at the same time, right? And that's kind of what the power of GraphQL when it comes to querying really is, right? That I can traverse a graph of data, and I can fetch in one API call, I can fetch data that is kind of related to each other, right? So on the Hasura side of things, what we do is we set up a relationship. And so we say that each user has an array of addresses. And so we use the user ID column to create the join, right? So this is telling Hasura that every user has something called addresses. Addresses is going to be an array of things, and you're going to use the ID column of the user table and the user ID column of the address table to figure out what pieces of data are related to each other. As soon as I add this relationship and I go back to GraphQL, and now I hit Control Space, you'll see that addresses turns up. I can now go in and fetch the address. Now you can see that I can kind of fetch data that belongs to a particular user, right? And so now in one API call, I'm fetching multiple pieces of data, right? And that's one of the key insights behind GraphQL. The idea that your data is basically a collection of nodes, and each of these nodes are basically related to each other. The idea that your API data models are basically structured like a graph. And what we're doing is our API is allowing application developers, people who are building web and mobile apps like us, to kind of make this query to fetch whatever information that we want, right? Of course, you can do things like every GraphQL server will have different kinds of parameters that you can pass to it. For example, I can say that I want to limit this to just one address. I don't want to fetch two addresses, right? You can even sort the addresses by, so let's sort that by the address name in ascending order. So now Bangalore comes first and then San Francisco, or I can sort this by descending order. Right? So different GraphQL servers will give you different abilities to kind of filter, sort, paginate, and do things like that when you're fetching that data from your graph, right? So this is kind of what GraphQL looks like. Let's take a look at what, and this is what reading data looks like, right? What we can also do is we can also insert data, or we can update data or delete data. These are what GraphQL calls mutations. In the rest world, you would have seen this as a post or a put or a patch or a delete. If any of you have used put and patch and delete in practice, that's awesome. In most of the applications that I've seen and that I used to build or that I used to be a part of, we would rarely use put and patch and delete. We would end up using post for almost doing everything. Although the REST specification says that if you're inserting stuff, you should use post. If you're replacing stuff, you should use put. If you're deleting stuff, you should use delete. And if you're updating a portion of a resource, you should use patch, right? So you had different REST verbs, so you had different HTTP verbs to capture that action. With GraphQL, that idea reduces to the idea of just having a mutation, right? And so a mutation is a type of a query that you're making to your GraphQL backend to mutate data, right? So it's an action that you're making to say, can you run this thing that is going to mutate the backend in some way? And mutations can be inserts, can be updates, can be deletes. They can be as complicated as you want them to be because you're writing your own mutation, right? In Hasura's case, we auto-generate mutations for creating, for inserting, updating, and deleting information, right? And just a second. Right. And so let's kind of take a look at what a mutation looks like. So I can insert a user, and by default, Hasura allows us to do a bulk insert. And I will insert the user with the name Joe, and with the email ID j@j.com. Now, whenever I insert a user, this is the data that I want to insert, right? And whenever I insert the user, I'm going to expect a certain kind of response, right? For example, in our case, the way we've modeled our data is that every time we make an insert, ID is automatically generated. So let's see what kind of responses we can get from the data. And this is the other cool thing about GraphQL, that when you run a mutation or you run a query and you want to capture responses, you don't have to refer to API documentation. I'm just going to do control space to see what all I can capture. So I can see how many rows got affected, which is nice. And I can capture returning information which has ID in it, right? And so if I run this, you'll see that I see that the ID that is automatically generated is 2, right? Let's insert a few more samples of this data. So I insert it again, I get ID 3. I insert it again, I get ID 4. Now, if I go back and make the same query again, you'll see that I have multiple objects, and the GraphQL query returns multiple users to me, right? So that's kind of what an insert mutation looks like. One of the really neat things about using GraphQL is, and the experience of using GraphQL that I was kind of showing you, was this kind of autocomplete experience where I was hitting control space. So let's kind of take a step back and think about how that actually works. What happens when you build or when you have a GraphQL API is that every GraphQL server publishes the types of the data that it has, right? And so our GraphQL server, in this case Hasura, is publishing a list of types that are available to Hasura. So Hasura says that we have queries and we have mutations. And when you're querying stuff, you can query for a user. And this is the structure of a user object. In fact, you can go to the docs here. And this is auto-generated documentation. And you can see that I can query for different things. I can query for a user. And these are the different arguments that I can give to a user. I can do pagination stuff by doing limiting. And I can also see what the user model is. So if I click on the user model, you'll see that this is kind of what the structure of the user model is, right? If I click on the address, you can see what the structure of the address model is. And this is kind of auto-generated. And this is a property that every GraphQL server has, which is that it publishes the types that are available to query, right? And what is happening in the background is that whenever I'm kind of writing GraphQL queries, Graphical, which is this tool that Facebook built and originally released with the GraphQL specification itself, this tool, whenever we load this tool actually makes a query to this GraphQL server and fetches the list of all the possible GraphQL types that are available. That's how I get this automatic kind of autocomplete experience, right? Because this tool Graphical has loaded all of the information from the GraphQL server and is able to kind of give me this autocomplete experience as an API, as a person that's using these APIs. So, so that's kind of one part of what GraphQL is, and one part of how Hasura itself works to give you a GraphQL query automatically on top of a database. What I'm going to show you next is how Hasura works on top of an existing database, and then I'm going to show you a sample integration with an Angular app. Just before that, I'm going to take a quick look to see if there are any questions or if there are any problems. All right, I think all is good. All right, cool. So, so now what I'm going to do is I'm going to connect to the database directly. So I'm going to Heroku and I'm going to capture the database URL, right? And I head here. So that's me connecting to the database directly. And this database is hosted on Heroku. Heroku itself hosts the databases on AWS. And so that's kind of the database that I have. And inside this database, you can see that I have these tables, right? And these tables are the tables that I made on the UI. So that's actually the data that is there inside these, inside the database that I made. What I'm going to do is to pretend that this was an existing database. I'm going to import a database dump that I had, right? So I'm going to run this data import. And now this kind of these tables are being created automatically, and some data is going to be imported. Just to show you what data I'm importing, let me show you a diagram of what this data looks like. I'm importing a music database. So there's going to be albums, and every album will have an artist, and every album will have a bunch of tracks. The track itself has a genre, and the track might belong to a playlist, or might be part of a playlist through a playlist track table, and the playlist track table has a playlist, right? So fairly straightforward modeling, and this is kind of fairly typical modeling that you'd have for an application, especially if you have a relational database on the backend. And that's kind of the data that I'm importing right now into our database. So the import is running as we speak. This is a tiny data set. It's just a few MB. So this import will keep running in the background. If I go back to Hasura, you'll see that Hasura says that we have these tables that are available, that are there in the database, but not exposed over GraphQL. So I can selectively expose some of them, or I can say, hey, you know what? Let's expose all of these tables over GraphQL. And then Hasura says, or detects foreign keys inside your Postgres database, and you have the option of converting these foreign keys into relationships, right? And foreign keys are a fairly standard way to think about constraints on relational databases. And so now what I can do is I can say, hey, you know what? Let's convert all of these foreign keys to relationships. As soon as I do that, and I head back to Graphical, let's see what kind of stuff I can query. So I hit control space again. And you can see that there's albums available now. And so let's query for albums. Let's see what fields albums has by hitting control space again. I have ID, I have title. That's cool. So these are the albums that are there inside the system. So this is the data that's getting imported here and the data I'm querying here. What I can also do is say, you know what, let me also see what artists, what the name of the artist is that made this album. Now I'm fetching that kind of related data with not just the album name, but also the name of the artist, right? And I can kind of start traversing the graph of the data that I have. So this is kind of one portion of how Hasura works on the existing database. I can do a few cool things. Let's say I can query for the number of albums that I have inside my database. So I can make an aggregate GraphQL query. This is because Hasura makes it easy for you to fetch aggregations as well. So you're not just fetching data now, but you're fetching the count of the number of albums that you have. You'll notice that this number changed because I was importing data. Let's see if we have tracks in the system. So these are music tracks. And let's fetch the total count of music tracks that we have. So you can see this number is continuously changing, right? And what's happening is that the number is changing because I'm importing data. What I can do is convert this query to a subscription. And this is the third piece of GraphQL, which is we looked at queries which was reading data. We looked at mutations, which was writing data. And now we're looking at subscriptions, which is subscribing to events. And in Hasura's case, any query is exposed as subscription so that you have a live query automatically, right? So this is the real-time component of GraphQL and the real-time component of Hasura, where if anything changes on the database and you have a subscription open that depends on that table or depends on the tables that are being changed, you will automatically get events which will have the latest result of the query that you're fetching. So you're noticing that this number is kind of going up automatically as this data is changing. What's happening underneath, right? Underneath this works with WebSockets. What's happening is that you have the GraphQL service itself, the GraphQL server has a WebSocket endpoint, and the GraphQL client, in this case my browser, has a GraphQL, has support for subscriptions. And so it's kind of opening up a WebSocket connection with the GraphQL server, and the GraphQL server is pushing new data to it as that data kind of changes on the backend. So that's what GraphQL subscriptions look like. And that's kind of how Hasura gives you GraphQL subscriptions. Now let's kind of see what the experience of using GraphQL APIs inside an Angular application is like. So before I go on to this part, I shall give you a full caveat. I am in no way an Angular expert. In fact, I just started learning Angular a few days ago. However, even somebody like me who does not know anything about Angular, I come from a React background. It's super easy to kind of get productive with GraphQL, right? And I hope that this kind of experience shows you what that looks like. So I have a simple to-do app, right? And this is kind of what the to-do app will look like. I'm going to show to-dos here, and then maybe I'm going to insert to-dos here, right? And now let's kind of start looking at the experience of what integrating that looks like, right? So ignore this bit for now. But this is my template. I just have a list of to-dos that I'm going to have, and somehow I'm going to get the to-dos from the backend. So for doing this, let's go ahead and create a to-dos table. And we have ID, which is going to be an integer. And we have title, which is going to be text. Set the primary key to ID. Cool. So I have a to-dos table. And let's say deploy Hasura, and that's a to-do. And then I have create tables, I have explore GraphQL, I have integrate, and so I have this data. Because I have this data here, I can start making queries to say, okay, let's fetch the to-dos ID and the title, and we know that our API is running. right? Now let's look at the experience of kind of integrating that API into an Angular application. So the first thing that you need to do is set up your GraphQL client. Let me just. All right. So our GraphQL client. So imagine that you had an HTTP client. If you had an HTTP client, you'd be using something like maybe Axios or Fetch. At least that's what I used to use in the React world. And so if you're using an HTTP client, you would kind of set up your HTTP client where you would set up what URL the HTTP client is going to be speaking to, and then every time you make a query, you would choose or define the path to which you're making the API call, and the HTTP method and the various arguments that you're passing to that API, right? So you'd say I make a get API call to /users with query parameter ID equal to 1, right? That might be a query. With GraphQL, you have different GraphQL clients available that you can use. One of the most popular GraphQL clients is our a set of GraphQL clients built by Apollo. So Apollo has a GraphQL client for Angular, and that's kind of what we're using here. So we've imported that Angular client here. And this is kind of what setting up a Apollo GraphQL client looks like. And so I think the key portion to focus on here is that we are creating the Apollo client. We're using a cache, an internal cache. And this is one of the cool things about GraphQL clients is that most of them support caching automatically on the client side. And all I need to do is kind of create an HTTP endpoint that our client will kind of make queries to, right? So I'm going to set up the GraphQL URL here, which is basically a GraphQL URL from here. Let me kind of go here first. And so I'm going to set up my GraphQL client here. So now that my GraphQL client is ready, what I need to now do is whenever I'm looking at a UI component, I need to fetch data for that UI component. I need to populate some kind of variable, and then I need to iterate over that variable, which is going to be a list of to-dos, and I need to render that on the UI, right? So if you go to a to-do list component, this is what the experience of integrating a GraphQL query looks like. Okay, cool. So let's kind of take a look at this code. I have to-dos, which is an array of to-do items. And the array of to-do items, I have type set up for the to-do, which is ID and title. Let's ignore this for now. I don't have both yet. And I have a to-do table here. And what I'm going to do with this to-do is that I'm going to make a query with Apollo to fetch that data and then populate that inside the to-dos variable. And then as the to-dos variable gets populated, it's going to get rendered in our UI, right? And the GraphQL query that we're going to use is we're just going to go to our graphical. We're going to take this query and we're going to copy paste that here. Format that a little bit. Apologies for all my backticks. And when we're making this GraphQL query, when we're setting Apollo up, we say that we want to make a query, and we use the GQL tag to kind of create the GraphQL query. So when we're creating the GraphQL string, we need to set that up like this. And that's where we're making the GraphQL query to kind of fetch that data, right? Cool. So that's the GraphQL query that's coming in. And this GraphQL query is kind of fetching our data. And that's the GraphQL query. And that data is the data response that we should be getting. And that's the data response that we want to be setting here. So let's take a, this to do is not rendering. So let's do a little bit of debugging to see what's going on. I'm going to look at my inspect element here to see what's happening. Sorry, folks, just a second. Right, so let's take a look at the GraphQL query that we're running. So I'm going to refresh this here. And I'm going to inspect the network tab to see what's happening in the background. Let's hit the network tab. And so that's the GraphQL. Sorry, folks, give me a second. All right, so there we go. I had a syntax error here. I apologize for that. And so that's kind of what my GraphQL query looks like. And then you're seeing that I get the response here, I get ID and title, and then I start rendering that here, right? So I'm not actually dealing with kind of making the API call, fetching the response, taking out pieces of the data, and then setting that up here. All I need to do is make a GraphQL query and then kind of start using, as soon as I have the data, I can kind of start using that in my template, and I can start doing that here. Let's look at the next portion of running a mutation with GraphQL and seeing what that experience looks like. I have another mutation component that's set up. So let's head to the add to do component. Now, if you look at the add to do component, I have a simple input box and a button. And the button has a handler, which will basically capture the input value that I have in the text box and insert that, right? Maybe let's change that name to add. Right. So, and so that's kind of what we want to happen. Let's look at the function that we have inside the add to do handler, which is labeled upvote, unfortunately. And so if you look at this handler, what this is doing is this is running a mutation, right? And if you look at this mutation, what I'm going to do is I'm going to run a GraphQL mutation that is going to insert just the title, right? So that's what the mutation looks like. And just to see that this kind of works, let's say add right? And we run this, but I'm not refreshing my UI, and so nothing is coming up here. But just to check if things have gotten inserted, you can kind of go back to a database and see if the to-do has actually gotten inserted. And so you can see that the to-do has actually gotten inserted. Before I show you what this syntax looks like, let's take a quick look at what GraphQL variables do. So imagine that you have a GraphQL API, and what you're doing is you're saying, hey, let's run a mutation where I want to insert a to-do. And I'm going to insert a single to-do object that has a title of test mutation, right? And then let's capture the ID when I have the response, right? And this is great, where I can fetch this test mutation. But if you look at this GraphQL query, I've hard-coded this value. But if you look at my code inside my Angular app, I can't hard-code this string. If I hard-code the string, I'll have to do something like string templating, where I capture this input value, this to-do value, and then I actually create that string to make my GraphQL mutation query. And this is horrendous, and you should never do this for various reasons, especially if your string has data that is not kind of encoded well, and stuff that you don't, and when you want to create that dynamically, right? If you start string templating all of your GraphQL queries everywhere, you won't be able to reuse GraphQL queries or keep your GraphQL queries in a separate file, right? And so when you think about that, what GraphQL offers is something called GraphQL variables. And GraphQL variables is an idea that allows you to make GraphQL queries dynamic. So let's take a look at what that looks like. What I can do is I can say, I'm not going to give you the title of the mutation during the mutation in the mutation itself. I'm going to call this something like, let's call it a new to-do, right? And I'm going to say that new to do is going to be something. It's going to be a string, and it's going to be a string that is going to be there outside this GraphQL query. So it's going to be something that you will get, that the server will get when the GraphQL query is made, but it's made at runtime, right? So when we make the query, we're going to send a new to do, which is going to be a string. And the way to send that is to send a variables object, and GraphQL gives us that autocomplete, and to say using GraphQL variables, right? And now this is sent separately from this. And you can see that this insert works, right? So this way, I don't have to hard code and create a GraphQL string that actually contains this variable. And if you look at the code here, that's what we're doing. We have a variables object that creates something called a to-do variable. And that's because in this query here, I've called the GraphQL mutation a GraphQL to-do. I've called it a to-do variable. And that's how that insert is working. Let me refresh this to see and load the kind of new to-dos that we've inserted. And you can see that the new to-dos are inserted here, right? So that's what running a mutation looks like. Fairly straightforward. The painful thing now, or the interesting thing now that we're going to look at, is how we can create a real-time component, right? And that's actually super simple. Let's take a look at our GraphQL module setup here. So earlier, if you look at the previous GraphQL module setup, we'd only set up the HTTP URL. When we're going to use GraphQL subscriptions, we're also going to set up a WebSocket URL. So let's go ahead and set up this URL here. So I'm going to change this. So what we're doing is we're saying, hey, we have a WebSocket URL and we have an HTTP URL, which is pointing to our GraphQL server. It takes a little bit more effort to set up a subscription client as well. In the previous version of the code, when we were setting up the HTTP client, we were just setting up the HTTP link, which was this bit. But now we're also setting up a subscription client. This allows us to now make GraphQL subscription queries as we need to. If you take a look at the code change that we've had to do, you'll notice that the only thing that has changed is that we've changed this from a query to a subscription. And the way that we're capturing data, we're using the subscription component from RxJS, we're using the and we're using Apollo subscription query type, right? And when we run the subscription, whenever we get new data, we just assign that data to our to-dos variable that we have, and then we just iterate over that to-dos variable that kind of shows up here. So now if I try to insert something here, saying testing subscriptions, and I insert that data, you notice that it comes up automatically here because it's kind of like a real-time update. In fact, I can go here and insert stuff directly in my database. And I can say, hey, let's go in and add a new thing, adding from my database. And you'll see that adding from my database comes up here automatically too, right? Let's clean this up a little bit so that we can see this a little more neatly. Cool. And so that's kind of what this looks like. I can in fact go in and delete my stuff here, and all of the stuff will change automatically, right? So let's make a delete mutation just to kind of see what a delete mutation looks like. Let's do a delete to-dos where ID is less than, so we have a less than operator where the ID is less than 5. And let's see how many things get deleted. Right, so we deleted 4 things. We deleted all the to-dos where the ID was less than 5. And if you go back to a real-time component, we'll see that all of those are kind of refreshed automatically. And so the experience of kind of integrating a real-time API is super convenient because you're not thinking about using WebSockets. You're not thinking about handling raw events. You're not even thinking about dropping connections, right? Even if the network gets connected and disconnected automatically, the GraphQL client will handle that for you. And as and when you get new events, you can just kind of start rendering that data, or you can treat that event as a notification and use that to refetch a query. right? So instead of kind of refetching, instead of kind of assigning this data here, we can also go ahead and kind of say, hey, let's refetch and reset to this, right? And you can do that as well, right? Instead of if your GraphQL server does not have live queries and your GraphQL server only has support for subscriptions as events, you treat the event more as a notification system and not really a live query system. In Hasura's case, Hasura gives you live queries, so you can kind of treat your subscriptions just like live queries. So that's kind of what, at a very high level, the experience of using a GraphQL query, a mutation, and subscription looks like in a super simplified Angular app, right? The next thing that I'm going to quickly touch upon is to show you how you can write custom functionalities inside on your GraphQL server with Hasura. So the cool thing with Hasura is that you get CRUD and you get real-time out of the box, right? And so you get CRUD and real-time out of the box fairly easily, but what if you need to add functionality that is not there in your database, right? What if you need to do a mutation that might do some super complicated validation and then needs to insert into 5 tables simultaneously, and then needs to maybe contact a different service and say that something has happened, right? Or maybe I need to query data and the data is not there in the database, but the data itself comes from somewhere else. Like, for example, I want to make a query to fetch the current temperature, and the current temperature is going to be there with the weather API. It's not going to be there in our database. And so that we call that the idea of creating remote schemas. And the idea of a remote schema is that you can write a serverless function or your own GraphQL API that is a super simple GraphQL server or a GraphQL resolver. And then you can just stitch that together with Hasura's GraphQL API. So let's take a look at what that looks like. So I'm going to use Glitch as my serverless provider. And for the next example, I'm going to use AWS Lambda as a serverless provider. And so I have this tiny index.js kind of JavaScript function set up here. And what I'm doing here is I'm writing my own GraphQL server. This GraphQL server does not have all of these different data types. It has only one type called a message, and that message returns a hello world, right? So the only thing that I can do is I can, just to show you an example, I can do query, I can do message, and that's it, right? It's a super simple GraphQL server that does nothing else but just this. And you can obviously change this to kind of do whatever you want. In fact, you can change this to have, you can actually change this to make an API call here. So in case you have a legacy REST API, you wrap that over with this kind of GraphQL definition. I'm using Apollo server for this, and Apollo server has great documentation on how you can kind of create this. And so what I have here, for example, is when I query for message, I'm going to return hello world. Let's see what our URL for this application is. So it's this. I'm going to capture this URL and I'm going to say hello, and I'm going to insert this here. That's our GraphQL endpoint. And now what I can start doing is I can start querying you see that I'm getting hello world here, right? I can change that to something else, which is data that I might want to run GTG. And I can, hopefully that's gotten saved, and I can kind of run that query again. And you see that this is happening, right? So if you have, and this is just a super simple example of a query, but you can have your own mutation, that does 4 or 5 things, or you can have queries that fetch data from different places, and that will automatically be merged with Hasura. So you can also continue making queries for your Hasura for stuff that's there in your database. I don't have name. So that's interesting because I don't have name. So I get a red underline that says, hey, you don't have name available in your schema. And this is why GraphQL is a joy to use. Right? And so I change this to title and I can fetch this. So we're merging the GraphQL schema that we are generating automatically and that you might have created yourself, right? And so now this combined GraphQL schema is something that you can start using in your application. The other kind of example that the other kind of logic that you frequently need to write on the back end is stuff that happens, when there's an event on your back end, right? And what we do for that is, and a very real kind of example for that would be, let's say we have users, and every time I have a new user, I want an email to be sent to me, right? And that's a typical example of saying that there's a mutation or there's an insert that happens, and when that mutation or insert happens, I want to execute action, right? This is very similar to the idea of having like Firebase Cloud Functions that execute with database triggers, except Hasura is kind of trying to give you that functionality on Postgres. So let's look at adding an event. And I go in here and I say, let's do a send email. And I want to send an email every time in the user table there is an insert, right? So I want to call this webhook, and this webhook will get the user that has been, the new user that has been inserted, and it will send the email, right? So where's this webhook living? I have this webhook code written here, which is using SendGrid, and it basically tries to send an email using the email ID that is present inside the data, right? So it's going to try to send an email, and then I take my JavaScript function that I have here, and I've deployed it on AWS Lambda, right? Which is again fairly straightforward to do. You just do a npm install, you zip the whole thing together, and then you upload your zip onto AWS Lambda, right? And AWS Lambda then gives you an HTTP URL that you can use to trigger that webhook. So I'm going to copy that HTTP URL. And let's configure that as our event trigger. And now let's go in and insert some data, which we can insert directly from here, or we can even insert it with a GraphQL mutation. So let's do a mutation to make that insert. So let's say mutation, insert user, and we have the name, which is going to be, and we have email, which is going to be ready. Let's capture the ID that we have in response, right? So we inserted this user, and now what should have happened is that I should have gotten an email on my email ID. So I'm going to go back and check if I have received an email, and turns out I have. And so that's the email that I've received from this email trigger, right? So that's kind of what integrating, adding your own code that needs to run after a particular event happens, or maybe after a GraphQL mutation happens, looks like when you're trying to do that with Hasura. So, so that's kind of at a glance how Hasura works and what kind of features Hasura gives you to kind of set up your CRUD and real-time stuff on the front end, where you're just kind of setting up tables on Postgres. You're using queries, mutations, and subscriptions in your app. And if you're writing custom business logic, you can write your own kind of GraphQL resolver that will get merged automatically by Hasura, or you can add an event trigger that executes when there are changes in the database, right? The last thing that I'd like to cover is a slightly more advanced concept, which is actually super important, which is the idea of securing access to your GraphQL endpoints, right? Because right now, any of you can actually just go to this endpoint and make a GraphQL query and delete all my data, which is terrible, right? And so what Hasura does is Hasura gives you a access control permission. And again, if you're familiar with Firebase, it's kind of like Firebase access rules, right? Sort of like that. And so what I can do is, let's look at our users table. What we can do is we can set up permissions so that, and the reason why I was querying everything was because I had an admin and I was just querying everything with admin. I can set up a permission to say, if I'm a user, only allow me to select data if the ID is equal to something that comes in from my session. It's something like a user ID. And this user ID typically comes in from your own authentication system, maybe like a Firebase or like a Auth0 or Passport.js or your own authentication system that you set up, or an enterprise, maybe an SSO provider or an LDAP provider, whatever it is. You capture some session variable here, and you provide a constraint saying, hey, users can only select data where the ID is equal to their session user ID. And inside the data, they can select only a particular set of columns, or they can select all of these columns, right? Now, when we make a GraphQL query, and let's say we use the role user, right? And I set the user ID session variable to 1. Let's look at what our autocomplete looks like. You'll see that I have message, which is my custom GraphQL schema, which is open to, which does not do authorization, where the authorization is handled in your code itself. But if you look at query, I don't get an autocomplete for any other of the fields, right? Because for the user role, we exposed permissions to select only on one particular table. And so I can now select user, name, and email ID. But when I make this query, instead of selecting data that belongs to everybody, I can only select data that belongs to me, right? And you can do this for inserts, updates, and deletes. And for inserts and updates, you can even set up more complicated things where you can restrict that the value, or you can do simple kinds of validation to ensure that data is not inserted incorrectly or in an unauthorized way on your database, right? The cool thing about permissions is that that uses GraphQL relationships as well. So in fact, I can set up permissions on the user table that might not use the ID, but I can set up a random permission that I can only access this if the addresses dot address starts with the letter B, right? It's just some kind of weird permission that I've set up, right? Or something like that. Right? So maybe this is a session variable that you have called, the name of your city, right? And only if the name of your city is present as an appropriate session variable, you can only then select data from the user table. So you can traverse relationships in the permissions that you set up as well. And this kind of allows you to set up fairly granular CRUD permissions for different kind of roles inside your application, right? And you need not only have user, you can have a manager that might have select to across all users, or might be able to select users that belong to the same organization, and complicated stuff like that, right? So that's how the Hasura permission system works. And if you're looking at authorization in your own GraphQL server, that will be something that you write in your own GraphQL service, right? Where you will capture the header, capture the authorization token, verify the token, return an appropriate response, right? And so that's where you're doing authorization yourself, which Hasura doesn't interfere with. So that's kind of what, that's kind of like a quick overview of how Hasura works, of a little bit about how GraphQL queries, mutations, and subscriptions work, and a little bit of an introduction to how you integrate that, or what an integration with an Angular application looks like. I can take questions. No, yeah. Sorry, just a second.
So until the questions come in, I have a couple of questions.
Sure.
So the first one, I noticed in your demo that Hasura in Heroku it was labeled as alpha version. Do you have a stable or a timeline for a stable version?
So we're planning to have a 1.0 out fairly soon, within a few weeks, along with some big announcements. But the reason why we have an alpha tag here is not because of the instability of Hasura itself. It's because we're still adding more features to the GraphQL API. Hasura itself is fairly stable. We have users running it on really large databases, on terabyte scale databases, fetching hundreds of millions of rows. In one case, I think for ProPublica, which is a large media newspaper in the US, they have a Gatsby app that fetches, I think, like 54 million rows, uses that to render a bunch of content on their Gatsby site. So Hasura itself is fairly stable. Even the event system, the remote schema system, and the GraphQL query system, including the real-time stuff. But the APIs are things that we're still adding to, which is why we have an alpha tag. But fingers crossed, we should be out of alpha very soon.
Okay, so in a couple of weeks, you said you plan to release version 1.
Yes.
Okay, and the other question, I think you mentioned something already. What's the performance on GraphQL? I don't know,
Yeah.
reported to REST or anything? Did you do some measurement, or do you have any, I don't know, insight of this, of the performance of GraphQL?
Yep. So I can perhaps talk about it in two different contexts. So one is the idea of GraphQL performance in general, and then one is GraphQL performance on Hasura. So if you look at building GraphQL services, and if you typically look at tutorials for building GraphQL services yourself, building a GraphQL server is very similar to building, not very similar, but it's kind of analogous to building a REST server. But instead of every route or every path being attached to a function, every GraphQL node is attached to a function, right? And then, so for example, let's say that I'm fetching, let me remove this here. So let's make a query to fetch the album information, right? So if you look at this query, what's happening is that you're fetching the album's information, and for each of the albums, you're also fetching the artists. So if you think about it, you're going to be running two functions. You're going to be running a function that fetches albums, and you're going to be running a function that knows how to fetch the artist information from the database. If you implement this in a naive way, what will happen is that for every album, the artist function will be executed again and again, right? So if I have n albums, I will make one query to fetch all the albums, but then I'll make one query per album to fetch the artist information. So I'm making n plus one queries to the database. Typically, you solve this problem by having what is called a data loader, where you actually end up making just two calls to the database. You make one call to fetch all the albums, and you make another call to fetch all the artists. But you make one kind of call to the database to say, hey, give me all of the artists where the album ID is 1 or 2 or 3 or 4 or 5 or 6 or 7 or and so on, all the way to like 347, right? And so you make two calls to the database. And this is fine, but this is not the best that you can do. What we do with Hasura is we actually are we're a compiler that compiles GraphQL queries straight to SQL. So, and of course, by adding the right access control rules as well. So if you click on the analyze button, what you can actually look at the underlying SQL query that is generated. And this is the SQL query it's the one SQL query that is hitting the database. And which is why, if you look at the kind of performance that you get for fetching this data, this is the response that I get. The response, the delay is basically the delay of the RTT between me and the server. So currently I'm in India, and my Heroku server is deployed in the US, and so I have like a 180 millisecond network round trip, and that's the delay, right? But the fetching from Postgres doesn't take time at all, because Postgres can handle this query super easily, right? As long as you don't make multiple queries to Postgres. So that's kind of the approach that we take to performance, and it's a little bit different from what you would do if you were writing a GraphQL server by hand.
So are there any more questions? Apparently not.
All right, cool.
Okay, so in that case, thank you, Tanmay, for your presentation.
Absolutely.
We wish you good luck with Hasura.
Thank you.
And who knows, maybe some other presentations.
Absolutely. And yeah, I think just to kind of wind up, I'd like to thank you for having me here, and whoever's watching, I would encourage you to kind of just try Hasura out, play with it a little bit, give us feedback. We're a very young open source project, and we're moving super fast. So let us know, try it out, give us feedback, and that'd be very 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 useful for us. So thank you, and have a good evening and a good night.
Thanks, you as well. Bye-bye.
Bye.